This is part 2 of solving normal distribution questions. So if you haven't seen the question related to this, at least just watch a few seconds from part 1 of this video and then come to this question so that you can understand what we're doing here and how this graph came about. Just a quick recap: our mean is 255 and our standard deviation is 8 milliliters. We're dealing with a volume. So we have milliliters here, and the y-axis has no label. And so the first part of the video explained how to solve these questions using the values we have of the standard deviations. So things like 247 and 239. So these values we have and we found, and so we use the percentages from the graph, the percentages we know. But sometimes the main question asks us that the packets of coconuts are advertised to contain 250 ml. So we want to know, for example, how many packets contain less than 250 ml. So we are looking at an area less than this part. So we want to know what is the area, or what's the probability that if I pick a packet, it's going to have an area less than 2, or a volume less than 250. And because 250 is not part of the percentages we know, and it's not part of the first, second, and third standard deviation, we can't use the percentages. And here's where you use your graphic display calculator, your GDC. And it's much easier to solve these questions using the GDC as well once you're learned to use them. So for this question, what you're gonna use is you're gonna press second and then go to var, and because you press second, you're actually not going to variables. You're not going to vars. You're going to distribution, and distribution will give you a list. You need to go to the second value, which is the normal CDF. Do not pick PDF, as it's going to give you the exact value at 250, which is not useful. And so you want CDF, so the cumulative probabilities here. And the CDF it's either going to give you the wizard where you put in the values, it's going to tell you what are the values, or it's going to open a bracket and you need to put the commas in between the value. So the first value you put in is the lowest value you have here. For the moment, the lowest value is not 220. Remember, these curves never touch the x-axis. They're asymptotic to the x-axis. The lowest value will be a negative infinity number. And so the way we represent it is by writing -1e99 or -9e99. It's up to you, as long as it's a big number. This number is actually -1 times 10 to the power of 99, which is a very big negative number. That's what you want, a big negative number. The E you can find by pressing second and then the comma, which is above your 7. You will find it as double E, but it's going to be written as E. Be careful, it's not the Euler E, it's a capital E. So you have your lowest value, you have your highest value. So we are taking all the volumes from negative infinity up to 250. So this is why we highlight our graph, it's because you can see clearly how what are your lowest and highest values. So 250, and then you write your mean, which is 255, and then your standard deviation, which is 8. And that's it. You just press enter, and it's going to give you the area as the area or the probability. So for this question, it's 0.266, which if I want to significant figures, if I want to round it, or if I want to, write it as a percentage, this is 26.6%. If the question asks you for a percentage, but since it wanted the probability, then we just write 0.266. And if it was the other way around, if you wanted the probability that it's greater than 240, so 240 is about here, and we want the area greater than 240, so this is represented by all of this. It's quite a big area. You repeat the same thing, however you change your bounds. So we have our normal CDF. The lowest value this time is 240. That's where we start. And it's going to end at positive infinity. So it's going to be a positive 199, 1e99, or 9e99, up to you, whichever you want, as long as it's a big negative number. Big positive number. And then your lowest, your highest, your mean, which is 255, and your standard deviation, which is 8. You press enter or you press paste, and it's going to give you 0.9696, which makes sense. It's quite a big area, so 0.96 is very close to 1. And so you can also round or write it in percentage, so you have 96.96% if you want to. The last part, or the most useful part of having a GDC calculator, is to find what we call the inverse normal. So this time we are given the area, but we don't know what value gave us the area, so we're undoing the process. So there's a specific A somewhere here, such that the area less than to it, so we're looking at the shaded area less than to it, is 0.75. Now, how do I know that it's going to be somewhere here? Well, it's because it's more than 0.5. Remember, the area less than the mean is 0.5, or 50%. And so this is going to be slightly higher, so somewhere here. And so this whole area is going to be 0.72. And in order to do this, again, you use the calculator, you press seconds, var, which will take you to distribution, and then you don't press normal CDF, you press inverse norm. And in the inverse norm, you write your area, which is the probability, and you have to write it as probability. So if you had this question as 72%, you need to convert it to 0.72, and then you write your mean and then standard deviation, so 255 and then 8, and this will give you 259.66. so just about here. The area underneath is 0.72. And the last part of this question, this video, is when you have a greater than area. This is slightly tricky, so try to understand that the calculator will only give you a less than area. When we wanted to find the normal CDF, we could actually specify the lower and upper bounds, but with inverse normal, the lower bound will always be negative and then up to your upper bound. Therefore, if I wanted to find a specific A such that the area is 0.16, the calculator will give me the reverse of the area. So hopefully we can solve it and then it will make more sense. So because I want an area 0.16, and 0.16 represents the greater than, it represents this part, I want to use the other part of the area, so the less than area. And in order to find it, I do 1 minus 0.16, and this will give me 0.84. And so, for example, if it's 260, the area above will be 0.16, but exactly 1 minus this area will give me the area below, which is what the calculator is able to calculate. And so I won't really have to do any extra step. All I did was just reverse the area, but they should be equal. So this is the probability that x is less than a is equal to 0.84. Okay, and the a should be exactly equal. I just reversed the less than sign. So again, you use the inverse norm. So inverse norm, and then this time the area is 0.84 with a mean of 255 and standard deviation of 8, and this is going to give you 262.96, so not too far from here. Just about there, just about roughly. So the area underneath represents 84%, but the area above represents 0.16 or 16%. And so we did actually solve this question, but you had to go through this step. So remember, if it's greater than, you have to subtract. Go through the questions in the book, try to understand how to, or try to practice more questions on these, and go through the past papers as well. But I've noticed your book has more questions on normal distribution. Hopefully these 2 videos were clear, and if you have any questions, either ask me in class or go through them again.